here's the documentation for everything that's in the machine. They just like tomorrow. So it's good. Yes.
So the question I have is, do you have any like large scale partnerships with any African countries? Like right now, we know what the Sudanese crisis is, a lot of West African countries, and also, what from a fiscal standpoint, like how much it costs to create one?
And my partnership is with the United Nations. I'm waiting. I talk to ambassadors all the time, or Colin and Apollo do. Come out and visit machines. They even wear their traditional garb. I mean, I've addressed the United Nations. The guy that owns Oracle, I met him in the lobby one day, and he was like, "You need to come out to my island." I said, "No, I don't." No, I don't. But I did save his card just to say I met the owner of Oracle. But I am not going to his island. No.
For like coastal or island regions like Jamaica or the Marines that have their abundance of seawater, why would an AWG be more viable than desal?
Oh, desalination. Let me tell you, desal. I'm a fish and I'm swimming by a desal plant and they're pumping the brine into the ocean. You're dead. The brine comes out, goes into the ocean, it makes a huge plume. Kills everything in its path. You know, off the coast of Saudi Arabia, it's like I lived in Australia. I've been in the water. Now, the lifeguards tell me to get out of the water because the sharks are coming. He didn't have to say that to me. I already knew they were coming. For 11 years. But you can jump in the water off the coast of Saudi Arabia and you aren't going to get bitten by anything. The ocean is dead. You know why they call the Dead Sea the Dead Sea?
The salt.
It's so full of salt, nothing can live in it. So desal, I was at a meeting in the state capital of Texas. I don't know, maybe they invited me in there to be candid. Companies were talking about how Texas is going to get out of this problem it's got with water. They're going to desal their way out of the problem, but they got to go get plastics plants, petroleum plants, whatever fishermen are left. They're not going to do doing that is we would do more damage to an ocean ecosystem that we've already damaged, maybe beyond repair. I wish we could do it if we could do something with that brine.
It seems like a pretty complex configuration. So my question is partly to that maintenance, like with the marine and the type of community that it is, usually isn't as advanced and has access to like larger scale of technology. So it's like with them having this type of technology, the community
We're telling folks that we can find the video, the full video of Black Women.
the longevity of it. Marginalized community, but then how long does it last? You know, like the impact that you want.
I got an answer. The question was, once you introduce something to a marginalized community, how long does something last? Hey, okay, there's new ways people build stuff, and there's other ways people build stuff. I don't know if y'all ever heard of a 57 Chevy or a 55 Ford or a Sherman tank. Hey, I'm old school. I'm building stuff to last. Like those old wash machines and things like that, those old Coke machines. I use steel. I don't use plastic. And I built some machines for the Marines. Now, one of my friends is in the room, he's a Marine, but not taking anything away from Marines. They're not always as smart as everybody else. Simplify. So, simplify. So, the Marines were sitting out on the island. They were over in Okinawa and Guam. And they were like, Captain West, we got a problem with the machines. And I was like, not a problem. Because when they bought the machines, they didn't have me take out the fuzzy electronics. I just built them and I sent them. So the machines there, I could tie into them just by having the IP address. I can operate the machines. We were sitting in the office at the factory, and we said, okay, we got the Marines on the phone, we're talking to them over in Okinawa and Guam. We said, okay, we're gonna turn your machine on now. They're like, Sarge, Gunny, is it on? Yeah, sir, the machine's on. He's way over there. We were operating the machine from here. I actually with it, added more to the program to it, adjusted temperatures, and did all that stuff from the office. So as long as the machine is built correctly, not like this stuff we build today, the throwaway society. You build it right the first time. You have connectivity to it so you can completely monitor the high side, the low side, how much water is producing, how much drag you have on the CFM because the filters might be dirty. The flow of water through the carbon filters because they might be clogged up. You tell the guy, hey, change the filters. So we can do the maintenance from here.
That's my next question.
Okay.
Parts. Do you have repair people around the world? Because machines are around the world. So if something goes wrong in Sudan, if something goes wrong in Hawaii, with the same system that you have now to accommodate parts.
Yes, what I do with the military is I send a spare parts kit.
Okay.
The things that could go wrong, they have a spare parts kit.
Got it.
Filter material, what I do is some units ask for the big bag of carbon, so all they gotta do is take their filters out, scoop their chargers filled, put them in, put it back in, they buy it like that way, and some of them want the cartridges themselves, but everything that are built is built for simplicity's sake.
Last question. How much would one of those machines cost, the big one?
The big machine, it depends on it. I would start at say 500,000, go south of that, $500,000 going south.
Quantity discount?
Oh, heck yeah. Definitely quantity discount. But right now, guys, I got to tell you, the price of steel has just,
It's going up.
I was talking to my manufacturer today because I got some work to do for the military. Steel's gone up 30%.
Is that 30%? Tariffs, right?
I think
Tariffs.
we have one more question over there.
I do have a quick clarifying question in terms of the comparison of your machinery compared to like desalines, the energy consumption, and the reverse osmosis and groundwater. So there's a lot of like energy intensive things in here, such as condenser and all of that. So I was wondering, in comparison to groundwater and reverse osmosis, how does that compare?
Cheaper. Groundwater is 0.1 kilowatts per liter to get it to you here. This machine, if it's sitting outside, is
I was talking mainly about the process, because it seems like you're going to get the condenser, you have to get the air to actually condense, and you have to
Right.
So I was wondering about the process in general.
for that liter. If I'm doing 5,000 liters, that 1 liter make it is 0.08 5,000 for the 24-hour period. So for your home water, 0.12 kilowatts times how many ever liters you use for the day. 0.08 is also running. That's with the fan running. That's going through the filtration system. That's for the operation of the machine, is that 0.08.
How did you get it to be lower than like groundwater? Groundwater is pretty reasonable, so I was wondering.
Well, the state of this is what groundwater costs. Groundwater is 0.12 for the state, what they pay, getting it out of the ground. And then when my machine runs, I have a PLC inside of the machine. It's recording kilowatts per hour. It's recording water temperature. It's recording humidity. It's recording pressure altitude. It's recording everything. So you have a complete run out of everything that machine just did for that every 5 seconds. And so it's infinitely cheaper.
Okay, I think we're at past 2 o'clock. I know there might be students here who have to go to another class, but let me just let's take this opportunity to thank Mr. West and they want 5 more minutes. minutes to say something, but Mr. West is gonna be here for anybody to chat with him. And we are going to try and get that machine on campus,
Well, I'm here.
this week, so. All right, thank you.
Hi everyone, I'm going to be very quick. My name is Jessie Nunez. I'm with the Imaginarium. I'm also a nonprofit. And my interest in atmospheric water generators, particularly with this audience, is I had well, let me back up. What we do is focus on anticipatory design and public interest innovation. So how do we anticipate all of the system failures that, is discuss whether it's environmental or structural, and how do we intercept that with technology like his. Basically traverse the earth with like a lot of other innovators, figuring out how we can put this into communities. We're working with a network of community land trusts so that each land trust manages this. And I had two very interesting conversations last week that I am going to just from NASA. They worked on what's called the GRACE project, gravity, don't let me mess it up. And that's been over the last 10, 20 years, and they've realized that there's so much depletion that it's doing everything from shifting the way our Earth turns to how it gets, and at that input, but it's also how do we build our buildings. People, we're talking to a lot of builders, and because most of the last 30 years in this industry has been mostly maintenance, there's not been a real generation of builders in a really long time. So we're speaking to a number of engineering students to try to figure out what are these new inputs and how do we deploy them quickly. The second conversation that kind of compounded the scenario is, it was someone from, he's had a long career, but he was at $8 trillion in maintenance deferral. What that means is every time we put off correcting infrastructure, whether it's a bridge, a school, or even government buildings, that adds up. And now it's so expensive based on conventional methods of desalination or all of the things that have already been in the playbook that they can't actually do any of that. It's too expensive. So for the questions of cost and the question of energy use, groundwater is cheaper in senses, but it still uses a lot of fossil fuels to pull it out, and that adds to it. If we are combining AWGs with new emerging technologies, then we're bringing down the already low rate even lower. So this has implications for cost. Now we don't have huge desalination projects to recharge water. Now we're figuring out how our buildings are built differently. And the way that we're sort of rolling this out in a slower way is called adaptive civic amenities. How do we take over underutilized spaces? Actually, we're doing a project called Habitable Harlem with the whole 3 square miles, where we're taking views and saying, what does a power station look like here? What does a water station look like here? How do we get different minds to contribute to how we build these systems, and how do we make them serve the public? But it's also industrial. So we're talking to companies like Carhartt, who have been around for a really long time. They're one of the few who have a domestic supply chain. And they're like, how do we get water without depleting water from the people who live around us, because they have neighborhoods and we're just making clothes. And then we're also talking to people like the only black rice mill in America. They want to open up a distribution center. They want to partner with, peanut butter manufacturers and do food hubs everywhere in these communities. But they're saying, how does our infrastructure need to look for that when we're washing the rice? How do we make sure that we're pulling that from AWGs? How do we steam it? Are we using solar? Are we using thermal? How are we producing cleaner food in urban farms if the water is cleaner? So I think the thing that I'm done now. But my interest in this tour that is going on and speaking to students, particularly in engineering, is because you actually are, based on feedback I've gotten from professionals, as you graduate, going to be the first generation in a very long time who has to build a lot from scratch. And so thinking about all of these new inputs, all of these new approaches to getting what we need to just survive is incredibly important. And I think it would give you a leg up if you could understand some of the things that have already been here but have been overlooked and not necessarily applied. This has been available for decades now, but it's just not, we're just now getting to a time where it makes sense structurally, and I'm done.
Paula, nice to meet you. Yeah, I feel like we spoke before. Yes. Yeah, yeah. How you doing? I didn't know you were in school.
I know, I graduated a few years ago, but